Okay, let's go for lecture 19, follow up to lab 7. Open SAT data, test if there is significant difference between college and high school GPA averages. Since the data are already separated in 2 columns, we do not need to do any preparation, sorting, cut, paste, etc. Just use the appropriate array 1, array 2, perform t-test. P-value should be 0.513. Okay, so let's do that. I have opened the SAT data. Let me directly go towards the t-test. So equals t-test, and since there are 101 rows, okay, so we start from A2 up to 101. So that would be A2 up to A101, comma, and high school GPA is B2 up to B11, comma 2 for 2 tail test, comma 3. So that's 0.51. That's our p-value, which is 51%, 51.36%, which is way higher than 5%. Okay. Statistical interpretation: since p-value is 0.513, larger than 5%, we do not have enough statistical evidence to distinguish between two averages. That's fine. Conclusion: although the college environment and student teacher relationships are very different from high school, college grading does not seem to be different. Okay, I do not agree with this kind of conclusion, since if we have a very large p-value, then we can't conclude anything just like that. Okay, why settle for inconclusives? Can't we just say that statistical analysis concluded the averages are likely equal? So here what we need to understand is, if the p-value is very less, then we can say that there is difference between the averages. Okay, but if the p-value is larger than 5%, we can't say anything. We can't conclude anything from that. P-value greater than 5%. So we can't conclude anything for larger p-values. If one computes the actual averages for these two columns, one get 1.98, 2.40486 respectively. These are obviously different numbers. So why does the t-test claim that the result is inconclusive? So let us go to this one and try to see this college GPA and high school GPA. So here if you just click this college GPA, then you can see the average is 1.98, and for high school GPA the average is 2.0486. So these are obviously different numbers. So why does the t-test claim that result is inconclusive? The t-test is not concerned about the difference between different averages. Instead, it is concerned about whether the difference between these two averages are statistically significant or not. T-test is concerned about whether. So t-test is concerned about whether the difference between the averages is statistically different. That's what it is concerned about. It's not concerned about anything else. So here it says we did not test if the averages of these two columns are different. They are clearly different. Instead, we tested if this difference is statistically significant. Okay, so that's it. Task 2, upload hurricanes data. The setup: there is a rumor on the internet that hurricanes with female names are more deadly than their male counterparts. Indeed, if one computes the averages during last 60 years or so, one finds that the average death toll for a hurricane with female names is 52.4 and male counterpart only 14.2. So are the two averages significantly different? What does the t-test say in this case? So I have opened the hurricanes data, and now I would like to categorize or sort this data according to the gender, okay, male or female. So it looks like that gender number 1 is female and gender number 0 is male. Click on the first cell and go to filter and sort, custom sort by gender MF. So that's fine. So these many hurricanes have male names. So let me mark it by a color, let's say blue, and let me mark the rest by another color. Suppose this one. Okay, that's fine. Now let's go for t-test. So equals t-test, and here it goes from F2 up to F31, comma F32 up to F94. Okay, so that's it. Comma 2, comma 3, and close the bracket, click enter. 0.20000664. So that's our p-value, which is 20% and greater than 5%. Okay, since data are scrambled, we need to separate male and female named hurricanes. We have done that. Thus one needs to sort by gender. Okay, after sorting, one can identify 30 male names and 63 female names. Performing the t-test, what is the p-value? So our p-value is 0.20. That's fine. What is the statistical interpretation? Statistical interpretation is that p-value is greater than, way greater than 5%. Okay, here anything means we can conclude that the averages are different. Okay, so that's fine. What is the conclusion? Since p-value is greater than 5%, so we can't say that we could not find. Okay, so we couldn't find statistical evidence or statistical significance between the difference between the male and female named hurricanes. Okay, let's click the answer. Although the averages are very different, the statistical test could not conclusively claim that they are significantly different. That's fine. Let's go for discussion question. Here's the chart for average hurricane death, female named hurricanes and male named hurricanes. Okay. So the average for female hurricanes death is almost 4 times, 52.4 versus 14.2. Why is this not significant? Is something wrong with the test? So here, if you go to this one, then the male named hurricane has average 14.2 and female named hurricane is simply 52.47. Okay, so they are quite different. The averages are quite different in this case, and it says, why is this not significant? Is something wrong with the test? So here, if you try to realize the data, okay, so number of deaths 4, 3, 7, 1, 5, 2, 15, 5, 2, 0, 12, 5, 0, and so on. Okay, and similarly, most of the hurricanes named female, they also incur similar number of death tolls, 2, 1, 0, 60, 20, 20, 200. It's very huge. Looks like an outlier since most of the death tolls are below 60. Here others also the similar kind of thing. Now here is another outlier. Okay, and clearly you can see this is the greatest outlier that you can have. Okay, but the others death tolls are fairly similar to what we have seen for hurricane named male named hurricanes. Okay, most of the hurricanes have similar except few. Actually, the t-test performed splendidly. The vast majority of hurricanes have very similar number of victims. But why are the averages so different then? Then you can see that we have discussed there are outliers. There are some outliers which affected the average of female named hurricanes. Okay. So we can say that in this case the t-test performed very good. Okay, so that's it. So data in question has several outliers, few hurricanes with astonishingly high death rates, and they have influenced the averages. Okay, but they did not fool the t-test. So surprisingly, t-test is a very nice test.